So in this particular formula we have to determine the surface tension by the capillary method, and the formula is given to you. So as we have seen in the class, no matter which formula you have, so in this case we have R H G divided by 2 into 10 to the power 3. Whenever we are finding the errors or the percentage errors, the constants they doesn't matter. So since we are supposed to find the percentage error in the tension, so that can be written as delta T by T, that will be equal to delta R by R plus delta H by H plus delta G by G. Now the diameter of capillary is given, the rise of water H is given, and the acceleration due to gravity is also given. So using all the values we have to find the possible error in the surface tension. Let's see how do we do that. Now delta R would mean the absolute uncertainty in the measurement of the radius, but what has been given to you is the diameter. Now R can be written as diameter divided by 2. So this is a linear relation, so I can write delta R by R, that is equal to delta D by D, where D is the diameter. Delta D would stand for the uncertainty in the measurement of the diameter. So in place of delta R by R, I can put delta D by D. Now the value of D which we have found out, which is the diameter of capillary, which is 1.25 into 10 to the power minus 2 meters, and delta D. So to find delta D, we have to observe this 1.25. There are two digits at the right of the decimal, right? So 0.01 will be the uncertainty, and you have to incorporate the 10 to the power minus 2. So this is your delta D. So let me repeat, you have to count how many digits are there to the right of the decimal. So in this case there are two digits, 2 and 5. That's why we have taken 0.01 as the uncertainty. So if I divide this, so that will give us delta R divided by small r. Similarly, to find delta H by the height H, the value of H or the rise of water, so let me just write it here. So delta H by H, in the denominator you can write 1.45 into 10 to the power minus 2 meters. Now to find the uncertainty in this measurement, we look at the value, how many digits are there to the right of the decimal. In this case also there are two digits, so which means 0.01 will be the uncertainty, and we will incorporate the 10 to the power minus 2 which exists in the value. This will be our delta H divided by small h. Now we find out the absolute uncertainty in the acceleration due to gravity, which is G, divided by the value of G. So G is given to you as 9.80 meters per second square. So how many digits are there to the right of the decimal? 2, right? So delta G would be 0.01 divided by the value of G is 9.80, right? So now we have the three values of the fractional uncertainty in the measurement of radius, height, and the acceleration due to gravity. So if I add all of this, let me give you the overall value. What we have to find, the possible error in the surface tension, so delta T by T, so that will be 0.8 plus 0.1 plus 0.7. so this is the percentage, so this should be multiplied by 100. So if I add all the three numbers on the right hand side, I'll get 1.6%, which is the percentage uncertainty in the measurement of the surface tension. So the next question is question number 8, which except Smaira all have done correctly. Smaira, you have not attempted this, so I would encourage you to solve it one more time before looking at the solution. So this is the question number 8. It's given that a body's distance and time are mentioned. We have to find the percentage error. So before this question we were supposed to find the velocity or the speed. So we have to find the percentage error in the measurement of the speed. So as we know that speed is nothing but distance over time, so if I need to find the percentage error in the measurement of speed, that will be delta D divided by D plus delta T by T multiplied by 100. Now the uncertainty in the measurement of distance, the absolute uncertainty is 0.2 and divided by the value is 13.8, plus the absolute uncertainty in the measurement of time is 0.3 seconds. Now we divide that by the value of time which has been found out, which is 4. Now if I multiply this by 100, so if I solve for this, so I'll get 1.44 plus 7.5. so on adding it, we will get 8.94%. So this is the answer to this question, the percentage error in the above problem. So next is question number 9, which Ayush, I think you have done incorrectly, so let's have a look. Now Ayush, I don't know what is the mistake which you have done here, but this is just based on the fundamental concepts. So in this particular question, the parameters b, c, d, e have been connected, and the formula is this: a is equal to b to the power alpha, c to the power beta divided by d to the power gamma and e to the power delta. Now we have to find out the uncertainty in the measurement of a, the percentage in percentage terms. Now the formula states, so according to the formula, the right hand side can be written as alpha delta b by b plus beta delta c by c plus gamma delta d by d and plus delta e divided by e. Now all of this multiplied by 100. Now the percentage uncertainties in the measurements of b, c, d, e are given to us as b1, c1, d1 and e1. So the right hand side can be written like alpha into b1 plus beta into c1 plus gamma into d1 plus delta into e1. So if you observe, so alpha b1, okay, so this is given in the option number D. So option number D is the answer to this question. Now coming to question number 11, Vaibhav and Somil have done incorrectly. So let's have a look. Question number 11. Alright, so parameters a, b, c, d have been connected in a formula to give you a physical quantity p. So we have to find the quantity which brings in the maximum percentage error in p. Again, this is pretty much basic. So if you want to find the percentage error in the measurement of p, so that will be 3 times delta a by a plus half of delta b by b plus 4 times delta c by c plus 3 by 2 times delta d by d, all multiplied by 100. So the question is the quantity which brings in the maximum percentage error. So all we have to do is we have to find out which quantity has the biggest of the coefficient. So if I consider the percentage uncertainty in the measurement of a, it has a coefficient of 3. So all you have to do is check which coefficient is the highest. So in this particular case, it is easy to note that 4 is the highest of all the coefficients. Now this 4 is related to c, right? So this means the parameter c will bring in the maximum percentage error. Now coming to question number 12. Now the image which I had sent you, now this image shows that all of you have done this incorrectly, but this is actually not true. I just cross-checked one more time, so the answer which you have found out, all 4 of you, this is correct. So option, let's have a look at the question itself. So it says that if there is a positive error of 50%, then the error in the measurement of kinetic energy. Now all of you have ticked option C as the right answer, which is the correct one. So my bad. So this, all of you have done this correctly. And now coming to question number 14. Somil and Ayush have done correctly, whereas Meera and Vaibhav have not. Let's see what was the issue in question 14. Vaibhav, I guess you have made an error. So you have used the wrong formula for volume. So in this particular case, it's given, the length of the cylinder is given and its diameter is also given. We have to find out the percentage error in the value of volume. So first of all, if you have a cylinder, let me draw the diagram. Let's say if D is the diameter and L is the length, and since diameter can be written as 2 times the radius, so the volume of a cylinder is given by this formula, pi r square into L. Now we need to find the percentage error in the volume, which means delta V by V into 100. So according to the formula, this will be 2 times delta R by R plus delta L by L into 100. Now delta R stands for the uncertainty in the measurement of radius. Now the instrument being used for measuring the radius or the diameter is the vernier calipers, and its least count is given 0.01 centimeters. Now the least count stands for the minimum distance which this instrument can make, which is 0.01. Hence the uncertainty in the measurement of radius is 0.01 centimeters. So let us write that value. So delta R, which is the absolute uncertainty, which is 0.01, divided by R, which is the radius. Now that will be equal to diameter divided by 2, but anyways it's given to you, the radius is 2 centimeters, so just write that 2 centimeters here, plus now delta L is the uncertainty in the measurement of the length of the cylinder. Now the instrument which is being used to find out the length of the cylinder is a meter rod, and it is having the least count of 0.1 centimeters. Least count, as I said, the minimum distance which this instrument can measure. So to measure length, delta L would be 0.1 centimeters divided by the length of this rod is 5 centimeters multiplied by 100. So if we solve all of this, so we will get 1 plus 2, which will give us 3%. Now 3% is the overall percentage error in the calculated value of the volume, which means option C is the correct answer. Now next is question number 15, which only Sawmill has done incorrectly. So let's check how to solve this question. Question number 15. So here is the question.